So just like when we had multiplication, what's the opposite of multiplication? Division. So that's like when we say the opposite, we mean the inverse. So the inverse of multiplication is division. Before, we had exponential functions, and the inverse of exponential are logarithmic functions. So logarithmic functions and exponential go together. They're like pairs. They're opposites of each other. So a logarithm base b of a positive number x satisfies the following definitions. So for when b is greater than 0 and b cannot be 0, we have log base b of x is equal to y if and only if b to the power of y is equal to x. So the first equation here is in logarithmic form. So that's log form. The second equation here is in exponential form. And we read it in log form as log base b of x. So that base is the b. And we can take something from log form and put it into exponential form. We can take something in exponential form and put it into logarithmic form. Bless you. So on the next slide, it takes something in exponential form and puts it into logarithmic form. So we start with the base. That becomes the base of our log. And then the exponent becomes the answer. And our answer becomes the other number. So I'm going to make an example so we can see it a little bit better. So let's say I had 5 to the power of x is equal to 10. And I want to put this into logarithmic form. Every time we put something into logarithmic form, we start with the word log. Logarithmic form always has to have that word log in it. Next comes our base. So our base is that 5 there. So it'd be log base 5. And then the other two numbers, we switch the order. So the 10 would come next, and then it's equal to x. So it'll be log base 5 of 10 is equal to x. And I'm also going to do an example of putting it into exponential form. So let's say I started with log base 2 of y is equal to 10. Or let's make a different number. 5. 6. I'll say 6. I hate like repeating the same numbers. So. All right. So we start with our base. What's our base here?
2.
2. So start with base. And then the other two numbers, just switch the order. So what would our exponent be? 6. And what's it equal to? Y. So 2 to the 6th power is equal to y. So for the first 2 pages of examples, all we're doing is rewriting it into whatever form it tells us. So here we're rewriting it into logarithmic form. So logarithmic form, we always start with the word log. And then what would my base be? 3. So log base 3, and then we switch the order of the other two numbers. So what would come next? 243 is equal to 5. Perfect. And that's it. All we're doing is rewriting it. All right, for the next one, what comes first? Log. So we have to start with the word log. And what's our base? 25. What would come next? 5. And then it's equal to what? 1/2. So log base 25 of 5 is equal to 1/2. Any questions here? Yes. All right, what goes first in the next one? Log. And what's our base? 10. And then what would come next? 10,000. So log base 10 of 10,000 is equal to 4. All right, in the next one, what comes first? Log. And what's our base? 6. So log base 6, what comes next? 1/6 is equal to -1. All right, and then the last one on this page, what do I start with? Log. What's the base? A. And then what comes next? C. And then equal to B. So log base A of C equals B. Next one. So here we're putting it into exponential form. So exponential, we know it's going to have an exponent. So we start with the base just like before. So what's my base here? 9. And then we switch the order of the other two numbers. So what would come next? What's my exponent? 1. And then what's that equal to? 9. So 9 to the first power is equal to 9. All right, for the next one, what's my base? 2. What's my exponent? 9. And then what's it equal to? 512. So 2 to the 9th power is equal to 512. All right, next. What's the base? 8. What's my exponent? 1/3. And what's it equal to? 2. Next one, what's my base? 4. What's the exponent? -2. And what's it equal to? 1/16. Okay, and then last one here, what's the base? B. What's the exponent? 0. And what's it equal to? 1. Any questions here? So this will help us when we do the homework. If you have a fraction as your exponent, can you see that? No. Let me change the color. So a fraction exponent. It makes the number smaller. If you have a negative number as your exponent, what does that do to your number? It flips it, so it becomes a fraction. So negative number exponent makes a fraction. And then the last one here, what does the exponent of 0 do to your number? It makes your number 1. So 0 exponent makes 1. All right, on the last page, we're going to be solving. So it'll say either evaluate or solve each logarithm. Here's where we actually have to solve. The other ones we're just rewriting. Now we're solving. So I have log base 2 of 16. This is going to be equal to some number that we can say x. Now, do we know how to compute logs in our head? No. But we do know how to do exponential equations. So I'm going to put this into an exponential equation. So what would I start with? 2. What's the exponent? X. Remember, we just switched positions. So 2 to the power of x is equal to 16. So now we have to think 2 to what power gives us 16? Let's see. 2 times 2 times 2 times 2 is what? 4. So 2 times 2 times 2 would be 8. And then 2 times 2 times 2 times 2 would be 16. So how many 2's do I have? 4. So 2 to the 4th power is 16. So what is x equal to? 4. So another way we can think about this, so just another way of doing it, which you can do it however you want. Here we kind of just did it in our head. We had to think 2 to what power gives us 16. But another way we can do this is we had 2 to the power of x, and it's equal to 16. How do I make that have the same base of 2? 16 would be 2 to what power? We just did it. 2 to the 4th power. So 16 is 2 to the 4th power. If our bases are the same, we can just cross them off and just set our exponents equal to each other. So x is equal to 4. So that's just another way of doing it if you wanted to work it out that way. All right, let's do the one right below. So log base 8 of 8, it's going to be equal to some number x. So what do I need to do first here? Put in exponential form. So what's my base? What's the exponent? X is equal to 8. So 8 to what power is equal to 8? 8 to the power of 1. So what would x be equal to? 1. Perfect. All right, let's do the one on the top right. Yes. So this is going to be equal to some number x. We have to find that x. What should I do first? Put it in exponential form. So what's my base? 49. What's my exponent? X. And what's it equal to? 7. So 49 to the power of x is equal to 7. This one's a little bit different because my number's getting smaller. So 49 to what power gives me 7? What type of exponent makes the number smaller?
A negative?
A negative does. Remember, a negative flips it. A fraction. So what would my exponent be? 49 to what power gives me 7? 1/2. Perfect. Because it would be 49 to the power of 1/2, which is 7. Because remember, 49 to the power of 1/2 is like saying the square root of 49, which is 7. So what is x equal to? 1/2. Any questions here? All right, and then the last one. So this is going to be equal to some number x. What's my base? 2. What's my exponent? X. And what's it equal to? 2 to the 5th power. So if I have 2 to the power of x is equal to 2 to the power of 5, what does x have to be equal to? 5. Because the 2's will just cancel, so now I'm just left with x is equal to 5. And that's it.